Graphing square root functions and cube root functions should be a review because they are part of your parent functions. Remember, the parent function for square root is y equals the square root of x. Your domain, when I graph it, remember the points you graph, easy to do domain when you see the graph. I can't do the square root of negative numbers because that's imaginary. That's coming on Monday. We're doing imaginary numbers on Monday. So the first square root should be 0. 1 is 1. You can do 2. If you take the square root of 2, you get a decimal. I just don't use 2 because I don't like graphing decimals as much. The square root of 3, more decimals. But there is a nice square root of 4. So what I do is I graph all the nice ones. 4, 2, 9, 3. And that's usually where the graph ends at 9. So 0, 0, 1, 1, 4, 2, 9, 3. I think it's a 10 by 10 graph. That helps you. And then it goes on forever on the right, but not on the left. Because we can do 16, 25, but we can't do negative numbers because, again, those are imaginaries. So the first x you can use is 0, and then you can go on from there. That makes the first y also 0, and it goes up from there. If I did 16, I'd get 4. If I did 25, I'd get 5. And your endpoint where it ends is here, 0, 0. But when we start moving it right, left, up, and down, that endpoint will change. So cube root, might as well do that one too. Y equals the cube root of x. With cube roots, hopefully, now that we've done a lot of cubes, 8 is a perfect cube. 1, 0, -1, -8. Cube root of 8 is 2. 2 times 2 times 2 gives you 8. Cube root of 1, 0, -1, -8. Remember, with cube root, now that you know cube roots, 8 is 2 times 2 times 2, so every 2, 1 comes out. So that's why the cube root of 8 is 2. 8, 2. If you're going to mess this graph up, you're going to make it go the other way. Meaning it starts up here and then goes down. But remember, the cube root of a negative number is negative, so it should start down and go up. This graph is always increasing. Both of these graphs are always increasing. So if you graph it the other way, that's wrong because it's decreasing. Negative infinity, positive infinity, going on forever to the left, forever to the right. The range is the same thing. It doesn't look like it's going up much. Well, that should be a 2. But it is going up, -2. Your turning point is the very center of this graph. It's kind of where you see it's going, to tell you the truth, it's concaving this way and then it's concaving that way. So it's 0, 0. And again, that will change too. And your turning point on the cube root is where those 3 points are right next to each other. So it's a good way to look for it. Okay, transformations. I'd like another page real quick. Our whole last chapter was on transformation. So I hope that you fast forward this video. We know this already. But if you do not, remember this is what you need to know. The negatives is a reflection over the x-axis. The A, if it is between 0 and 1, so 0.5, 0.25, it's a vertical compression. If A is greater than 1, 2, 3, 4, it's a vertical stretch. Inside your radical, if it is a positive H, that means I had to plug in a negative number, so negative number would be going left. If it is a negative H, that means I plugged in a positive number, and positive numbers are going to the right. So if what you see is positive, it's going to the left. If what you see is negative, it's going to the right. And then the outside one is definitely the easiest. On the outside of your radical, if it's positive, it's going up. If it's negative, it's going down. So when you start these questions, the first thing I want you to do is to describe the transformations. So here, this is going left 1. and down 3. Well, I know the numbers I used for the original are 0, 1, 4, and 9, but I want to move all those to the left. Left 1 means I'm going to subtract 1. So I'm going to do negative 1. Let me get my left. 1 minus 1 is 0. 4 minus 1 is 3. 9 minus 1 is 8. And down 3, I can subtract 3 from my y's. So negative 3, negative 2, negative 1, 0. Or you can just plug in points. If you try to plug in 0, you get negative 2. If you plug in 1, you'll get a decimal because you'll get like the square root of 2. So that's why I moved my x values left or right, depending. And then if you move those x values left or right, you can just plug it in, like the square root of negative 1 plus 1 minus 3. Well, this is 0. The square root of 0 is 0. 0 minus 3 is negative 3. Then you can do it with 0. 0 plus 1 is 1. The square root of 1 is 1. 1 minus 3 is negative 2. Then you can change that to a 3. 3 plus 1 is 4. The square root of 4 is 2. 2 minus 3 is negative 1. Then you can change that to an 8. 8 plus 1 is 9. Square root of 9 is 3. 3 minus 3 is 0. So you don't have to know the transformations for y's once you get the transformations of x's. So negative 1, negative 3. 0, negative 2. 3, negative 1. 8, 0. And you should know what the graph looks like because we're just moving that one down and to the left. There we go. Endpoint is negative 1, negative 3. Range, domain is now from negative 1 to infinity because it's moved to the left. And range was now moved down 3, so negative 3 to infinity. Left and right affect your domain and range. I guess we can stay with square root. All right, so with this one, the negative is going to reflect it over the x-axis. And then move it up 6. So none of that is going to affect the x numbers I plug in. So I can use the original that I was using, 0, 1, 4, 9. And then plug it in. The square root of 0 is 0 times negative 1. It's still 0 plus 6 is 6. The square root of 1 is 1. Negative 1 plus 6 is 5. The square root of 4 is 2. Negative 2 plus 6 is 4. Square root of 9 is 3. Negative 3 plus 6 is 3. So 0, 6. 1, 5. 4, 4. 9, 3. Nothing affected my x values, so my domain did not change. My range got completely flipped upside down, so now it's actually going to negative infinity, and it's stopping at 6. So start at the bottom, work your way up. It's going negative infinity, going down forever, and then it's ending up here at 6, which is my endpoint, 0, 6. People get bracket happy. Make sure your endpoints are points, so write this in parentheses. All right. This transformation minus 2. If you think you're good and you can do these, go ahead and try these on your own. Pause the video. But this is right 2, and that affects my x values. So this is cube root. So I'm using 8, 1, 0, negative 1, and 8. But if I'm moving those right 2, 8 is going to become 10, 3, 2, 1, negative 6. If I plug 10 in, 10 minus 2 is 8, and the cube root of 8 is 2. 3 minus 2 is 1, cube root of 1 is 1. 0, -1, -8. So my y's didn't change because I just moved all my y. Oh my goodness, my x value is right too. 10, 2, 10, 2, 3, 1, 2, 0, 1, -1, 6, -6, -8. That's not right. That'd be like way down here. That'd really look wrong. -2. Because that'd be -8, and the cube root of -8 is -2. Can get. I counted to 8. All right. 8, 7, 6. There. There we go. Our turning point's that middle. So 2, 0. And the domain and range of cube root is easy. Negative possibility. Negative possibility. Okay, transformations. The 2 is a vertical stretch by 2. Plus 5 is going to be left 5 and up. So left 5, I'm moving all those original points left 5. So I'm moving -8, -1, 0, 1, and 8. Left 5. So I'm going to minus 5 from all those. So I get -13, -6, -5, -4, and 3. And then there's 2 transformations happening to my y values. So it's kind of easier just to plug in these new numbers and then get your y values. So we're doing 2 times the cube root of the numbers we chose. So the first one was -13 plus 5. I'm not doing this right. Oh, I am. Plus 4. 0. So it's -13, -6, -5, -4, and 3. So 0, 2, 4, and 6. 0, 2, 4, and 6. And 8. -13 is off the graph because it's going by tens. -6. -5, 4. -4, 6. 3, 8. So it's curving this way, and then it's curving that way. And you know you're not going to cross the x-axis until you get to 13. So make sure you don't graph it like that, because I'd take points off. That's wrong. Because you're going to -13, it's going to 0. So it's that way. So it actually might be even worth graphing it so you can see when it crosses. Something like that. Turning point is right here. -5, 4. And there's your graph. Hopefully yours is a little nicer than mine. Mine looks nice. All right. So remember, when you're graphing left and right, you do move your x values. If you did not want to plug it in, what you're doing is you are taking your original y values way up here. and you're timesing them by 2, vertical stretch of 2, and then moving them up 4. So negative 2 times 2 is negative 4, plus 4 is 0. So negative 13, 0. I flipped the y's, the x's by accident. My bad.